Welcome to this eLearnSecurity video training lesson on nmap and port scanning. In this video, we are going to use a popular tool called nmap to perform port scanning on target systems. Port scanning helps the presentation tester to determine what is running on a remote computer network. To understand how to use nmap, we can open a terminal window and type man nmap. If we scroll down, we can see a lot of information in the manual and even a couple of examples of how to use nmap. The important part for this lesson is host discovery, using the -sn parameter to figure out what hosts are running on the network. We will also go through a scan technique like TCP/Y SYN scan, which can then be launched with the -S parameter, and the TCP connect, which can be launched with the -S T parameter. We will also see how to define specific ports for our scan by using the port parameter, which is -P, and at the end, we will use the -S V parameter to perform a service version detection. To start, we will first use nmap to discover what hosts are available in the target network. To do this, we can start the nmap scan using the -SN parameter to do a ping scan of the address range we provide. We can provide the IP address range in a couple of ways. First, using the range by specifying a starting and ending address separated by a minus sign. The second way is to use a CIDR notation, which is a range specified by a slash and a number. Here, /24 is the same as our previous 0 to 255 range. We will use these interchangeably during this lesson. Now that we have our command completed, we can start the scan. Soon, we will see the results begin to populate, and we will see that the scan is finished when the prompt returns. In the results, we can see that nmap tells us if the specific host is up, the latency, the MAC, and the IP address of the target. In addition, nmap tries to guess what network card is used by the target, as indicated in the parentheses. Now that we have completed this scan, we will try to output the results of the scan into a file to be able to refer back to the results as needed. To do this, we can retype the nmap command, and we will append the greater than symbol to tell our system to send the results to a file called hosts-up.txt. Note that we won't see any results returned to the screen since they are directed to the file. We will know when the command is done because the prompt returns. To verify the file, we can cat or list the content of the file hosts-up.txt. As we can see, we have the same results of the previous scan. Now let's try to scan a remote host. Simply run the command nmap followed by the IP address of the machine, which in our case is 192.168.102.138. After a moment, we will see the results start to populate on the screen. We can see that the system is up, the latency, and there are 992 filtered ports, but above all, we can see a list of ports that are open or closed. We can identify the state of each port by checking the state column, and the service associated to each port by checking the service column. Basically, what we have done with this scan is to run a default scan, which is a SYN scan. We can accomplish the same scan by using the -S parameter to identify the type of scan for nmap to use. Similarly, we can also use the TCP connect scan parameter by specifying the -S T. The difference between these two scans is that the connect scan makes a full TCP connection with a three-way handshake, completed to the port on the target machine. This can be time-consuming and can also alert the target machine that someone is looking at the system. And it's generally logged by the target system. By using the SYN scan nmap only, the initial SYN packet is used and stops after receiving the knowledge packet, which stops the connection process, bypassing most logging features and alerts that may be in place on the target system. Now we will scan the target using the TCP connect scan, which is the T, and also use the port command or the -P command to specify that we only want to scan a single port, which in this case is the port 80, the IP range that we want to scan. This will return results for any system in the range that have the 80 port open. As you can see in the results, there are many hosts that meet our scan parameter. Note that we see a new state here which is filtered. The differences between the states are simple. Open means that nmap can connect. Close means that nmap cannot connect. And filtered means that nmap is not sure of the exact state of the port. Generally, filtered is a result when nmap doesn't get a response. There are many reasons this can happen, such as a firewall filtering the port, or an intrusion detection system in place filters the response. If the port status is closed, it generally indicates that nmap received a packet indicating that the port is closed, such as a reset packet. The important thing to remember about ports is that when we find the filtered status, we do not give up on them. We need to try some other techniques to test if the port is really not open. Besides using the single port definition in nmap, we can also run a scan on a range of ports. We will try the same scan again, but with a port range from 0 to 100. In the output, we can see that nmap has returned the system with any port in the range from 0 to 100. Knowing the open ports is important, but it is also important to know the service that is running on the specific port. To do this, we will use the -s capital V parameter. To show this, we will use the command nmap -s capital S -s capital V -p21, which will do a SYN scan on host port 21. As you can see in the results, nmap tells us that the specific version is an FTP shell FTPD6. Now, with this information, we can go online and find vulnerabilities for the specific version of the service. Or we can download the software and run it locally to identify a vulnerability that can be exploited on the remote machine. Similarly, we can use the same type of command to find out more information on a range of IP addresses. So now, we will take the same command and we will run the scan on all of the default ports. Once the results return, notice once again that we have the details of the service version running on the open ports. We can see FTP server found before and Apache HTTPD 2.4.10 with PEN SSL1 and PHP 5.4. On the other hosts, we can see Microsoft ESMTP6, LightTPD 1.4.29, and OpenSSH 6.0 Debian. As you can see, nmap can return a lot of good information on your target system. And this concludes our training video on port scanning. Thanks very much for watching.